Hello, I am Krishnamurthy Pammi. In this video, we are going to learn a quality management tool called Activity Network Diagram. Whenever we are asked to develop project schedule, we wanted to have complete knowledge about various attributes of project activities involved. That means how the project activities are interconnected with each other. What is the early start time, early finish time, late start time and late finish time of each of the activities involved within the project? What is the critical path of the project? And what is the project duration it takes to complete the project? And also how much time an activity can be delayed so that the project end date is not impacted? What is the amount of time an activity can be delayed so that its succeeding activities start time is not impacted? All these kind of activity attributes we need to have. Then only we can arrive at efficient project schedule. Using activity network diagram, we can achieve this purpose. Activity network diagram can be represented either by activity on arrow method or activity on node method. We use activity on node method in this video to represent the activity network diagram. The activity network diagram is also called critical path method. Let us understand the activity network diagram in detail. Using activity network diagram, we can calculate early start, early finish, late start and late finish of an activity. Let us understand these terms using an example now. In our example, let us take an activity called commute to office by an employee. So an employee takes 1 hour to reach his office from his home. So the activity name is commute to office. The duration is 1 hour. Let us say an employee can start at the earliest at his home by 8:30 a.m. So early start is 8:30 a.m. So to get early finish, we have to add duration to early start. So early start 8:30 a.m. plus 1 hour is early finish. So early finish is the earliest time an employee can reach office is 9:30 a.m. That is earliest finish. So it can be obtained by the formula early finish is equal to early start plus duration. Let us suppose that the employee must be there in office by 10 a.m. So the late finish of this activity is 10 a.m. So the activity must finish at the greatest or latest by 10 a.m. Now to get late start, that means the greatest time or the latest time an employee can start at home is 9 a.m. How you obtain? Late finish minus duration. That means late start is equal to late finish minus duration. So using this kind of thinking pattern, we arrive at early start, early finish, late start and late finish. The formula is early finish is equal to early start plus duration. That means early start plus duration is early finish. Late finish minus duration is late start. So using this formula, we can obtain early finish, early start, late start and late finish of an activity. Let us draw an activity network diagram using an example. Our example consists of building 2 new features to the already existing feature set of our product. Now, as part of this, we will be performing requirement analysis, we will be performing design, building, functional testing of these features, and then we will be doing integration of these features to the already existing feature set, and then we will perform regression testing to ensure that already existing features are not disturbed and they are performing in the intended way, and then we will deploy and release these new feature set along with the existing features of the product to the market. We are asked to draw activity network diagram by giving the details provided here. The activity description requirement analysis is represented by activity A. Design for feature 1 is represented by activity B. Design for feature 2 is represented by activity D. Build and functional test for feature 1 is represented by C. Build and functional test for feature 2 is represented by E. Integration testing is represented by I. Regression and release activity is represented by R. Now, we will learn what the predecessor means in following slide. the duration for each of the activities are listed in this particular column. That means activity A takes 5 days, activity B takes 6 days. Likewise, the duration is listed in this particular column. Let us draw a rough draft of activity flow from the details provided here. Activity A has no predecessor. That means there is no activity that comes before an activity A. That's how activity A comes as the beginning activity. For the activity B and activity D, activity A is the predecessor. That means for both activity B and activity D, activity A comes before. This is how it is represented in the activity flow diagram. Now, for the activity C, activity B is the predecessor. For the activity E, activity D is the predecessor. For the activity I, activity C and activity E are the predecessors. Similarly, for the activity R, activity I is the predecessor. Now, a clue is an activity that has no predecessor is the beginning activity. An activity that is predecessor to no other activity. For example, if you see R is not featuring in the predecessor set. That's how R is the ending activity. So this is how we can draw a rough draft of activity flow diagram. If you apply activity description for these activities, it looks like this. It shows a beautiful meaning. It says that requirement analysis is performed for both the features first, then designing and building and functional testing of feature 1, designing and building and functional testing of feature 2 are carried out in parallel, and they both are integrated here, and then finally regression and release is performed. So using activity flow diagram, we know what is performed first, what is performed next, what activities are performed in sequential way, what activities are performed in parallel way. For example, B, C activities are performed in parallel to D and E. So this is how our activity network diagram is looking like this. Let us calculate early start and early finish for various activities in our activity flow diagram. Now, all the activities in our activity flow diagram are tied up with finish to start relationship. For the activity A, it can get started at the end of 0th day. That's why early start is 0 and duration is 5. So if you add duration 5 to its early start, it becomes early finish. 0 plus 5 is equal to 5. So the early finish for the activity A is 5. Now, this early finish will get carried forward as early start for activity B because activity A and activity B are tied up with finish to start relationship. In similar way, activity A and activity D are tied up with finish to start relationship. So the early finish of activity A will get carried forward as early start for activity D. So the early start for activity D is 5. So if you add duration, 5 plus 6 is equal to 11. So early finish of activity B is 11. Similarly, 5 plus 4 is equal to 9. So the early finish for activity D is 9. Now the early finish of activity B will carry forward as early start for activity C because they are tied up with finish to start relationship. So similarly, the early finish of activity D will carry forward as early start for activity E. Now, if you add duration for C, 14 plus 11 becomes 25. That is the early finish of activity C. 6 plus 9 is equal to 15. So that is what is early finish for activity E. Now look at the beauty here. From here, you are getting 25 as early start for I. From here, you are getting 15 as the early start for activity I. So what we should take? We should take maxima in forward pass. Why? Because activity C and activity I are tied up with finish to start relationship. Similarly, activity E and activity I are tied up with finish to start relationship. So for the activity I to get started, both C and E must first be finished. So it has to take 25 because even though the activity E is getting finished at the end of 15th day, the activity I has to wait till end of 25 because it has to require C to get completed. So because activity B, C need to be completed, the activity I has to wait for this flow. That's why we'll take maxima in forward pass. So from one side you are getting 15, from another side you are getting 25. So out of 15 and 25, the maxima is 25. So we will take 25 as the early start for activity I. Now, if you add 5 to 25, that means duration to early start of activity I, you will get early finish as 30. Now, this 30 will get carried forward as early start for activity R, because activity I and activity R are tied up with finish to start relationship. Now, if you add 5 to its early start, 30 plus 5 becomes 35, right? So this is how we calculate early start and early finish for our activity flow diagram for various activities. Let us calculate late start and late finish for various activities in our example. The late finish for activity R is 35, which is equivalent to the early finish of activity R because of maximum duration here. Now, using the formula, late start is equal to late finish minus duration. That means we must deduct the duration from the late finish to get the late start. So 35 minus 5 is 30. So 30 is the late start for activity R. Again, in the backward pass, this 30 will get carried forward as late finish for the preceding activity because they are connected with finish to start relationship. So the late finish of activity I becomes the late start of activity R. So this 30 is getting carried forward here in backward pass. Now if you deduct the duration from 30, 25. So 25 is the late start for activity I. This 25 will get carried forward to activity C and activity E as the late finish. So if you deduct duration from the respective late finish, that means for activity C, 25 minus 14 becomes 11. This 11 is late start for activity C. Similarly, 25 minus 6, which becomes 19. This is the late start for activity E. Now, this 11 will get carried forward here in backward pass. So this is the late finish for activity B and 19 is the late finish for activity D. Now, if you deduct duration, that means 11 minus 6 is 5 for activity B. This 5 is late start for activity B. 19 minus 4, 15. 15 is late start for activity D. Now this 5 will get carried forward here and from here 15 will get carried forward here. So 5 is getting carried forward here in backward pass. 15 is getting carried forward in backward pass. Which one to take? Now in backward pass we must take minima because activities are connected with finish to start relationship. So out of 5 and 15, 5 is minimum. So 5 becomes the late finish for activity A. Now if you deduct duration 5 from the late finish, you will get the late start for activity A. So you got the late finish in backward pass using the formula late start is equal to late finish minus duration. We now have the early start, early finish, late start, late finish using this representation for all the activities using the formula early finish is equal to early start plus duration, late start is equal to late finish minus duration. We are calculating early start and early finish using forward pass and we are calculating late finish and late start using a backward pass. Let us understand how to calculate critical path and project duration for our example. Now, using the representation early start, early finish, late start, late finish for an activity, we have all these attributes listed for the activities mentioned here. Now, in our activity network flow diagram, we have two paths. One is path 1, A, B, C, I and R. Another is path 2, A, D, E, I and R. The total duration of path 1 is 5 plus 6 plus 14 plus 5 plus 5, which becomes 35 days. The total duration for path 2 is 5 plus 4 plus 6 plus 5 plus 5, which becomes 25. The critical path is the longest path in scheduled network diagram. So the critical path is A, B, C, I and R. So the activities colored in maroon color are critical path activities. So the critical path duration is 35 days. So if anybody asks us how much time this project takes, I will say minimum 35 days I need. Why? Because 35 days is the critical path duration. So minimum 35 days I need to complete this project. So critical path is the minimum duration a project takes to finish. So from critical path we arrive at project duration. Any delay to the activities on the critical path will further delay the project duration. So that's why we do not have any float on critical path. Remember, I use the term float. Float of an activity or total float of an activity are one and the same. They both are synonyms. So, a float of an activity is the amount of time an activity can be delayed without impacting the overall project end date. It can be obtained by either of the formulas late start minus early start, late finish minus early finish. If you apply this formula for any of the critical path activities, you will find the total float or float as 0 for critical path activities. This is obvious because we cannot delay the critical path activities. Any delay we do to the critical path activities will delay the overall project end date. That's why usually the critical path activities will be having 0 float. In advanced project scheduling, you may find a situation wherein it can be negative, but that is beyond the scope of this lecture. Usually, the total float of critical path activities are 0. When it comes to non-critical path activities, okay, you will find certain float. By applying the same formula, late start minus early start for an activity D as 10. So 15 minus 5 is 10. So that means the activity D can be delayed up to 10 days. So the project management can consider incurring delays up to 10 days so that the project overall end date is not impacted. So that's the beauty of the float. So similarly for the activity E also we have the float as 10. Late finish minus early finish, 25 minus 15 as 10. So activity E can also be delayed up to 10 days under special circumstances. So if we incur delay more than 10 days, then the critical path will change because the project end date is changing and the critical path will change from ABCIR to ADEIR. So we cannot have delay more than 10 days on this path. So that's the beauty of knowing the term float for an activity. There is another term called free float of an activity. Free float of an activity is the amount of time an activity can be delayed without impacting the earliest start date of any of its succeeding activities. If you take activity A, the free float of an activity A is the amount of time activity A can be delayed without impacting any of its succeeding start date, early start date of activities. That means early start date of activity B and early start date of activity D or the succeeding activities of activity A. So how much time I can delay? 0, because the activity A is finishing on 5th day and activity B and activity D must start on 5th day. So the free float is 0. Obviously, the free float of activities on the critical path is always 0 because we cannot delay critical path activities. But when it comes to the free float of activity E, if you see here, the free float is 10 because the activity E is finishing at the end of 15th day, and even if I delay by 10 days, its succeeding activity I is not impacted because the succeeding activity I is starting at the end of 25th day. So 25 minus 15 is 10. So 10 is the free float of activity E. The difference between free float and total float is, in free float we are measuring activity with respect to the early start date of the succeeding activities. Whereas in total float, when we consider total float of an activity, we are concerned about total project end date. That's the difference. The terms free float and total float gives you the scheduling flexibility available in the activity network diagram. Thus, activity network diagrams helps in efficient project scheduling of a project or process activities through determining precedence and succeeding activities, sequential or parallel order or sequence of activities, early start, early finish, late start and late finish for an activity, critical path and project duration, free float and total float for an activity, the amount of scheduling flexibility available. Thus, not only arriving at efficient project scheduling, this activity network diagram also helps in identifying schedule risks within the project or process activities involved. I thank your interest to learn and I look forward to add more value add sessions in future. Thank you.